Thank you for coming, everyone. I'm going to talk a little bit. Partly I'm going to talk about my project, where the light where we meet, which you can see over here as well. But I'm also going to talk a little bit more generally about what generative art is. I know there's like some people in the audience to whom that's not like a super familiar term, and like the way that we make it might not be something that you're super familiar with. So I'm going to try and like show you a little bit about that, basically. So first of all, a little bit about me and my history. I have kind of a combination in my past of like technology and art. There's kind of like a joke that it's so common for people to say like my work exists at the intersection of art and technology, but like that it's true, it does. So I'm just going to say that. In the past, I've made some work that's been these kind of large immersive installations. So I built this one during my master's, and it was a geodesic dome that you could go inside, and it was filled with LEDs. And there's like a little gap that has a camera, a Kinect camera in it. So it uses infrared light to detect distances. So I wrote an algorithm that detected any movement in the dome. So if people came into the dome, they could like wave their arms around, like dance, anything, and the lights would react in real time to what they were doing. So it was kind of like a space to hang out, and it was a very like collaborative experience. That was kind of what I was aiming for, that it was a space for people to spend time together and enjoy like an interaction with some artwork. And then when the pandemic happened, I was like, well, I can't make interactive immersive art festivals. So I started focusing more on code-based art. So I've created lots of generative artwork in the last, what is it, like 5 years now. So this is a piece called Maplands. This is Forecast. This one was Meaningless. This was on Art Blocks, and this one is Matter Waves. But the thing about each of these pieces is that every one of them is made up of lots of different artworks. So each piece doesn't just have one output. Like I don't create one artwork, I create lots of artworks. And that is one of the key things about generative art. So what is generative art? Yeah, like I say, it's kind of, we don't make the final piece. We're making a system or a recipe that creates those final pieces. So it's kind of, yeah, kind of like creating a recipe for a cake instead of creating the cake itself. So there's often sets of rules. So a rule could be something like draw 500 circles on the screen. And then we often include randomness as well. So each one of those 500 circles could appear in like random positions over the screen. And then there's also the fact that those things come together in a system, and we often are recreating natural systems. Not always, but often we take inspiration from natural systems, things like birds flocking or the way a beehive works. Those kind of things are very common inspiration, or actually, as in the case of my piece that I have here, it was inspired by the way that fireflies sometimes synchronize their flashing, and I'll talk more about that later. So I'm going to attempt a bit of a live demo, which I think probably half the audience is like, oh no, why? So yeah, but hopefully it'll go okay. So yeah, I've got this piece here that I coded in advance. That I've got my code on the left over here. Maybe I'll just make that a little bit bigger. And then over here on the right is the output. So every time I refresh this, it's generating a new output on the right. And currently it's like incredibly simple. It's just drawing 4 stars onto the screen. And I can change up here where I've got a number of stars. I can change that. So currently it's 4. It could be 40, and then we immediately get 40 stars or 400. We can, let's not go too high or it might crash, but yeah, lots of stars can be in there. So this is already like a really simple generative system, and the instructions are just place this number of dots on the screen, give each of them a random position, and give each one a random color from a pre-selected set. So there's 4 different colors that it can possibly be here, like green, blue, pink, and purple. And there's a few different things we could do here. So we could change this layout from random to circular. And there's some code elsewhere that I've created in advance that now is making sure that all of those dots are appearing within a circle. So that's like another rule now that we've added to our system. We can do some cooler things as well, like within the stars. Instead of choosing completely random colors, we could choose the color based on the position of the dot on the screen. So right now it's like a dot down here would be completely purple, one over here would be dark blue, up here is light blue, and here is light green. And within that as well, we can sort of jitter the position of them. So if I change this value to zero point 0.4, we get a bit more transition, maybe 0.3. We get a bit of a transition of the colors. So you can see it's still sort of fading from like light colors at the top to dark colors at the bottom, but there's a bit more variance within it. So each dot is looking at a slightly different position to pick up the position of color that it's going to use. And this is actually the exact same technique that I use in the piece that I have here to place the colors. So if you look at those pieces, you can see there's like a transition or a gradient of the color across the screen. Another thing that I've added in here is about 10% of the time. So randomly, 10% of the time, it completely chooses a random color and makes the dot bigger as well. So we could go down a whole path here and, play around with like the placement of the colors. We could, instead of using just circles, we could use like different shapes. We could create like all kinds of different shapes. But instead, we're going to create a constellation. So I'm going to remove some of this color stuff. And let's make the stars a little bit smaller. What do you want? Actually, let's go 5 to 10 pixels wide. And then we'll come back to about 50 stars. And I'm going to add in this piece of code here, which is now going to find connections between the stars. So what it's doing is each dot looks at all of the other dots and works out which ones are closest, and then it chooses a few to connect to. So there's some options that we can do here as well. Like right now, each dot is picking between 1 and 3 stars to connect to. So completely randomly, it says, I want to connect to 1. A different star might say, I want to connect to 2. But we could change it so they're connecting to many more. We could go back up here and connect to lots of stars. It's quite cool also if they're only connecting to a few. And then I can also, instead of, like I said, they're randomly choosing how many to connect to. So some dots are connecting to one other dot, some are connecting to 10 others. But we can change it so that the number of dots they choose to connect to changes across the canvas. So from left to right, let's increase this a little bit. So we've got way more connections happening over on the right-hand side of the canvas than the left side of the canvas. And I'm going to lower the opacity of those connections as well. So it creates like quite a nice effect. Let's make this a bit smaller as well. And maybe some more stars. Oh no, I think I typed too many. Oh no, it's okay. So there's another thing that I can add into this as well. I've got this other piece of code about missing areas. So if I add in one missing area, it will create an area where there's no stars happening. Actually, if I comment that bit out as well. And let's make these a little bit bigger. So yeah, it's creating these kind of blank areas within the constellation. And I've got what we would refer to as a debug mode on this as well, where you can kind of see the outline of those areas so we can see what's happening. This is something that we do quite a lot in generative art, is create these modes where we can see the extra bits of what's going on to help us when we're coding. And often I post them on social media and then they're more popular than the artwork. But yeah, I think everyone is familiar with that. So I think people like to see like a little bit behind the scenes, So yeah, we can create some more missing areas here as well. And then I can also alter it. So instead of completely not putting any stars in those areas, we sort of bring that down a little bit. It's just reducing the number of stars in each area. And again, yeah, every time I refresh, you can see it's creating a completely new, different piece. And that is because each one is seeded by a different place of randomness, which is what is happening with all of these pieces. And if you didn't know already, like every piece in the room is being seeded at once by the same source of randomness. So as they all refresh, like each piece is using the same hash to seed the randomness. But obviously they've all got completely different algorithms going on. So all of the outputs are completely different. And it's similarly here, every time I refresh it, it's creating something completely different. And then just, yeah, one last thing is this piece, so that in the middle of those missing areas, it creates some stars. So we get these like extra little constellations like within the main constellation. So yeah, that's like a little demo of the code. Didn't crash my laptop. Very happy about that. So hopefully, yeah, if you didn't know much about generative art before, I know lots of you in the room literally are generative artists, but if you didn't, then yeah, hopefully that's given you a little bit of an extra idea of what it is and what we do. But yeah, so the piece that I have here today is this is a still from it. So I'm going to talk through it a little bit about how I created it. I've actually got a video. I screen record it a lot of the time actually when I'm coding. And I did screen record when this was first being created. So this is about a minute long video that is was originally, I think, maybe 2 hours of coding. So it's just sort of sped up into a time lapse. And my initial idea was to create paths that, as they travel around the canvas, if they hit another path, when they intersect with that other path, they stop. So my initial thing was creating these kind of circular paths. And then I'm sort of experimenting with lots of different things within those circles, like different amounts of bend, or like, I think initially also I was thinking of them very much as paths, whereas they ended up being shapes. So I was experimenting with highlighting different colors within the paths. Those lines that appeared in a grid, that was splitting the canvas into areas. That's a debug view actually again. So I'm splitting the canvas into areas so that when I look for intersections, I only have to look within the relevant section rather than looking over the whole canvas, because it can take a long time to do those sorts of checks. And then at the end here, I was starting to use the idea of creating shapes within those paths, instead of just using the paths. And I was initially doing that by basically trying to fill each pixel in turn. And when I hit a boundary of a path, I'm like, okay, well, it's a new shape. So I pick another color and go on to the next one. And then I think I was having trouble doing it. So I was like, this is going badly. And I stopped screen recording at that point. And I actually ended up doing it in a completely different way. But I also did the paths in a completely different way. So you can see, like, in that screen recording, they were very circular. It was all just like curves and circles placed in different ways. But I ended up with things that look more like this. So it's using Perlin noise. So you can see, like, this is an example of some paths moving around the canvas using Perlin noise. It's basically every step of the way, it's making a decision about which angle to turn in. So it could choose it completely randomly. So every step it could go like in a completely different direction, and you get these like really wobbly paths. But instead it uses something called Perlin noise, which is basically like a grid of random numbers. But every random number is similar to the numbers nearby. So you can see here, if every number is translated into an angle, each arrow is not that far away in its angle from the ones nearby it. So you can see as the path moves around the canvas, it's sort of following those arrows up, and then when it goes to do the other end of the path, it's following the arrows but backwards, because it's the opposite end, and it kind of creates these pathways through. And then you can change what I refer to as the resolution of Perlin noise. So this is with a much sort of more zoomed in resolution. So the numbers are very similar to each other, and you can create different types of curves. So within the final pieces, I get things like this where I've got like different sort of types of angles happening across the screen. Yeah, I just included this because I find it really interesting to like see like graphs and sort of artifacts from coding. I actually have a post-it note that says, something like the brain is no place for serious thinking, and if you're thinking about something complicated, write it down. And I find that incredibly true. Like I can't think about things like this just in my head. Like I have to think about it between my brain and the paper. And this was working out the paths for the agents as they move across the screen and as they intersect. How when they hit an intersection, do they go back to the other end of the path and go from there, or are they already done? And like all of that sort of like computation and figuring those things out. So yeah, just to share that. And then I ended up with paths like this. In some of them, I also have some sort of predefined geometries, so like circles, basically predefined geometries. So it's like they're circles and squares, and sometimes paths as well. So like with this one, there's like zigzag lines, and yeah, in this one you can see really clearly there's like some different settings for the purlin noise. So here we've got like really smooth curves, and then over on the other side, like more tight turns. So it's choosing settings by location on the canvas. So yeah, as I mentioned, that I have these paths, and then they go from paths to shapes. And the method that I did that with is called a planar graph. I have this article about planar graphs. I suspect not many people want to listen to somebody talk for 20 minutes about planar graphs, so I'm not going to. So if you'd like to learn more about that, then you're welcome to go and read that article, and I'm happy to chat about it as well. So this is a video of the final piece and where I ended up. I couldn't get my speaker notes, and I feel like there was something I was going to say about this specific, but I don't remember what it was. Oh yes, so the animation. Once the paths are laid out and the shapes come together, the animation that happens is based on the way that fireflies synchronize their flashes. Certain species of firefly synchronize their flashes. So each shape is looking at the other shapes nearby it and thinking about whether it should flash or not. So as well as sort of having its own ideas about whether to flash, it's looking at its neighbours. So I've got a little video of this happening in fireflies, and you can see it starts in a second, this kind of pulsing through the way they're flashing. So not all species of firefly do this, but yeah, some do. And the way that works is that each firefly, has its individual clock. So this is like one firefly here, and the clock is just kind of going round and round in a cycle. And then when it hits a certain point, it flashes. But then when another firefly is introduced, when this second firefly flashes, this one's clock jumps forward. And after a few rotations, they end up flashing at the same time. This is quite like a crude demonstration of it because it's only affecting it in one direction, whereas obviously in a swarm, like they all affect each other. But you can see after a while the flashes happen at once. So that's the kind of inspiration for what I did here. And you can see once one shape starts flashing, like the flashing spreads out over the canvas. And this is a system where each shape within the swarm or the canvas has its own personal autonomous control. So there's no like central control over the whole thing saying like this area flash now, this area flash now. It's each individual one is just looking at itself and looking at its neighbors, and similar to how things work in an ant colony or a beehive. And I find that kind of system really interesting, how that distributed control can come together to produce like an overall effect over the whole system. So that was why I wanted to create it for this project. That's it. So yeah, happy to take any questions.
I wanted to know if I don't know much about coding, and I don't know much about art. I want to know if there's any kind of pushback from traditional artists. So as an artist, I might say I have a canvas, and then I choose to put this here, here, and here. Whereas you mentioned this is partly randomness, and the end result you might not know what it is. So is there any pushback from that traditional artists against this?
Yeah. Yeah, no, yes. Yeah, definitely a reasonable question. I mean, this kind of art has been being made since like the 1950s. Like it's not a new thing. Like ever since there's been computers pretty much, like people have been playing with them and experimenting with them. So there is like a long history that we are building on these days. But I'd say there's still definitely pushback. Like, we're not in the huge like traditional art galleries as much as we'd like to be. And I think also with AI now as well, like there's often confusion, like this is not AI art. Like I write code and I do use AI tools to help me with the coding, but that's a completely different thing from creating art with AI. So there's some confusion with that now. So I often, like when I post this online, and I'm sure other artists as well, get comments about like, oh, it's AI art, but it's not. So that there's like a whole new level of pushback now as well. But I mean, I think it is getting more and more accepted, and I think within the art community, like we're all quite conscious of that, and like thinking about ways that we can incorporate ourselves in the traditional art market, but also there are things about the traditional art market that are not ideal. So trying to work out different ways to do that, like with the blockchain. And yeah, I think hopefully it will only become more and more accepted, I think. Thanks.
I've got a question. So you said the biggest, in the video that you showed us, there was a point where you got frustrated and you said it wasn't going the way that you wanted it to go.
Yeah.
So in this specific project, what was the biggest challenge, or what was because for me, the whole thing is just so amazing and creative. What was the biggest challenge for you on this specific project?
Yeah.
And can you explain it in a way that I would understand, please?
I'll do my best. Yeah. Yeah, I think probably that bit with the piece of paper where I'd like sketched out like what happens in each scenario with like the intersections, and like when a path ends, do we need to sort out the other end of the path, or is this path already sorted? And because some of the paths are like these predefined shapes, those need to be treated kind of differently. I got really like stuck in the weeds for a while with that. But actually the thing about putting the shapes together from the paths, that was easier than I expected in the end. Like that I was able to sort of follow like a pre-existing algorithm to do that. So it was just a case of like implementing it. So that's probably the hardest. Yeah.
So I'm curious, when you work on a new piece, and what do you have in mind first? Is it more of an algorithm, a system, and you are probably then surprised what the visual outcome is, or do you have a picture like this already in your mind, and you think, okay, what kind of rules would I need to create such sort of picture?
Mm-hmm. Yeah. I think personally, I often have a picture in my mind, and then I code that thing, and then it looks like something else, and then that gives me another idea. So it's quite like a iterative process of like with this, it was way more about the paths in my mind in the beginning. Like I didn't think about turning them into shapes until later. So I'd intended that like, yeah, it would be very like just about the paths and like different sorts of paths and so on. And I did have a specific image in my mind, which is not very similar to what is there. But sometimes it's about the concept as well. Like I've been doing a lot of stuff with my a coded version of my handwriting, and that's a lot more like conceptual, I think, like from the outset. Whereas often I find that I have an image or an algorithm or something that I want to try, and then it develops over time. And then there are sort of concepts that I think about as I'm creating it that end up being like the concept of the final piece. Thanks for the question.